Hello everyone. Here we are going to discuss the Newton's gravitational law and Cavendish experiment to find out the value of the capital G, which is a gravitational constant. First of all, we have two spherical masses m1 and m2, and the distance between the center of their spheres is small r. And Newton's gravitational law tells us that if two masses m1 and m2 are close enough, then there will be the attractive force between these two masses, and which is force F is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. And if we convert this proportionality into equation, then we'll get the F is equal to the capital G m1 m2 by r square. And this capital G is proportionality constant, which is called gravitational constant. And its value is capital G's value is 6.63 into 10 raised to power minus 11 Newton meter square per kilogram square. And this force, the magnitude of force is between m1 and m2. The question is which mass m1 or m2 exert the force on which mass. Either the m1 exert the force on m2 or m2 exert the force on m1. The answer is the m1 is exert the force on m2, which is the attractive force towards the m1, and we can say that it is a force on 2 due to 1, and it is a vector quantity. And here we can also say the m2 exert the force on m1, and it attracts this m1 towards the m2, and this force F is called F12, which is the force on 1 due to the 2 attractive force. And according to the Newton's third law, we can say that these force F12 and F21 are force are equal in magnitude but opposite in direction, because these are the mutual force. F is a mutual force between M1 and M2. As we can say, we can see in this equation F is equal to capital G M1 M2 by R square, and we can see that this force is the mutual force, which is also depends on the magnitude of m1 and m2, and it implies that we can say the f1, the force on 1 due to 2 and force on 2 due to the 1 are equal in magnitude but opposite in direction. Now we discuss the Cavendish experiment to find out the value of G. How we can find this value of G is 6.63 into 10 raised to power minus 11 Newton meter square per kilogram square. Here is a simple experiment in which the two identical masses M1 small m and small m are at the ends of a massless rod whose length is capital L, and this is the massless rod between the identical masses M and M. And this identical rod is also vertically attached with a string, and the fine string, and this is attached to the ceiling somehow. If we bring the capital M mass between this small m and capital M mass between this small m, as we discussed earlier, the two masses m, small m and capital M, there will be the attractive force between these two masses m and capital M, and there is also a attractive force between this small m and capital M. This attractive force will be equal to F is equal to the capital G small m capital M and divided by r square. Here is the r is the distance between the small m and capital M, and there is also an attractive force between these two masses, small m and capital M, and F is equal to the capital G, the small m, capital M, and r square. Because of these two forces, which are equal in magnitude but opposite in direction, and this string will be twisted, and there is a torque acted on this string, and the magnitude of torque is directly proportional, or we can say that the magnitude of torque is equal to the perpendicular distance between forces and multiply the magnitude of either force. And now torque can be written as this: the perpendicular distance between the forces, these two forces, the perpendicular distance is capital L, which is the length of the massless rod in the capital L, and the magnitude of force we discussed here, the F, is equal to the capital G, small m, capital M, divided by r square. And due to this torque, we can say this is equation 1. Due to this torque, the string will be the twisted, and there will be the torsional torque in the string, and that torque is directly proportional to the angle theta, which is subtended at we can measure if we place a needle or the mirror with this string, and it implies that the theta is equal to torque is equal to proportionality constant is c theta, and this c is proportionality constant, and it depends upon the string proportionality constant, and it depends upon the string, the nature of string, how stiff and soft is the string. These two torque at equilibrium will be equal, and we can say that equation 1 and equation 2 are equal. Sorry, this is equation 2, and capital L, capital G, small m, and capital M divided by r square will be equal to and c theta, and it implies that we can find out the value of G from this equation. This G will be equal to c theta multiplied by r square and divided by capital L, small m, and capital M. As the value of c theta, if we plug all the values in this equation, then we will get the value of G is equal to 6.67 into 10 raised to power minus 11 Newton meter square per kilogram square. Sorry, here is 6.67. Thank you for watching.